we're currently inside the CTO measurement wagon of TUDelft. So this is really something unique at TUDelft. In addition to the excellent professors, academic staff, students, including PhD candidates, and also the lab facilities, we own this very unique, very special measurement train. And this train is a moving lab. You can do a lot of measurement, a lot of tests, all kinds of technology within this platform.
Het researchprogramma van ProRail is een onderzoeksprogramma gericht op de stabiliteit en het gedrag van spoordijken bij intensiever treinverkeer. Het doel is om te onderzoeken wat de gevolgen zijn van meer en zwaarder treinverkeer op spoordijken en de ondergrond, inclusief de invloed van klimaatverandering op de ondergrond. Maar ook hoe hierop gericht onderhoud gestuurd en aangepast kan worden. Het is een samenwerking tussen ProRail, TUDelft en Deltares. De beoogde resultaten zijn modellen en methoden voor het voorspellen van verzakkingen, ontwikkeling van methoden en technieken om het gedrag van spoordijken en de ondergrond te monitoren en tenslotte het ontwikkelen van oplossingen om de infrastructuur betrouwbaar en veilig te houden.
Between Delft and Schiedam, we have a higher concern about the stability of the embankment. There are multiple reasons that raise this concern or raise this interest. First is that the embankment there is normally quite high, and also the soil is quite soft. It's a very typical example of the Dutch soft soil. And also the water level is high in that region, especially in the season of this year, almost winter time. So that's why we run this train, not just our measurement wagon, but also with 10 very heavy locomotives to have this slowly or even fast moving heavy load to do all the measurement, all the analysis and assessment that is needed in this project. Laser Doppler vibrometer LDV is a measurement technology that measures vibration of the target. It works based on the so-called Doppler effect. It means that when a laser or a wave is on a target, the movement of the target will change the frequency of the wave or the laser. Then the system can demodulate how much this movement is from the laser. So laser measures vibration like this, and it is a non-contact technology. It means that we don't need attach a sensor to the target, but instead we simply shoot a laser on top of it. This makes our life much easier if we want to measure something that is not that easy to attach a sensor. For example, a railway track or a rail especially. Previous project at TUDelft, we have successfully demonstrated the effectiveness of the laser Doppler vibrometer technology for measuring rails, fasteners, sleepers, and now we're extending its applicability to embankment, which is an important substructure to monitor and to assess.
Ground penetrating radar, or GPR, is a non-destructive geophysical method which lets us look at the subsurface without needing to dig the ground. It works based on sending short electromagnetic pulses into the ground. When these electromagnetic waves encounter subsurface with different material properties, for example different composition or moisture content, part of the energy will reflect back to the surface. On the surface, these reflections will be recorded and analyzed to prepare images of the subsurface. Later on, these images will be processed and interpreted to know the exact truth of the ground. What is new in my research is to make much more accurate interpretation of GPR data, to make it much more reliable for continuous monitoring of railway embankment. When ground is uniform, these electromagnetic waves travel smoothly. But when there is a change in the subsurface or embankment, for example, wet zones, soften of the soil, weak layer, or voids, the electrical properties of the subsurface will also change. This causes the radar waves to reflect it back differently, either stronger or weaker or distorted. By studying these differences in the reflected signal, we can identify anomalies or irregular patterns which can be related to the problems of embankment. In the long term, this project will help to create a data-driven monitoring framework which can be applied to the Dutch railway network to make a much more efficient and safer infrastructure management.